So critical angle, what is a critical angle? The angle of incidence is known as critical angle if angle of refraction is 90 when light travel from denser to rarer medium. So when the light travels from denser medium to rarer medium, the angle of incidence is known as a critical angle. So example, a light strike at an angle of 30 degrees from the normal. This angle was 30 degrees and it refracts or changes the direction or bend away from the normal with an angle of 80 degrees. Is this a critical angle, the angle of incidence moving from glass to air? Is this angle of incidence a critical angle?
No.
So it is not a critical angle. Why? Because the angle of refraction is not 90. The condition for angle to be a critical angle or angle of incidence to be a critical angle if the angle of refraction is 90. So if we further increase the angle of incidence, I further increase the angle of incidence, so that angle of refraction or refracted ray travel along the boundary. So what is the angle of refraction here moving from glass to air? So the angle of refraction is 90 because angle is always measured from the normal. So from the normal, if the this 90 is not known as a critical angle. The angle of incidence, like example, if angle of incidence was 42. So if angle of incidence is 42 and the angle of refraction is 90, so what is the critical angle? So the critical angle is 42. Don't say critical angle 90 because critical angle means the angle of incidence, not the angle of refraction. So angle of incidence. So when we increase the angle of incidence, the angle of refraction will also increase. At a certain angle, all of the light will travel along the surface or along the boundary, and we call the angle of incidence as a critical angle. So if I increase this angle more, the angle of refraction will also increase. And eventually, the angle of refraction will be 90. When the angle of refraction is 90, we call that as critical angle. So as we are increasing the angle of incidence, the angle of refraction is also increasing. At a certain angle, the light will travel along the boundary. So when the angle of refraction is 90 or light travel along the boundary, the angle of incidence can be critical angle or known as a critical angle. What will happen if we increase the angle more? So what will happen? Like if I draw a simple figure, you have 4 different figures in which the light strike the boundary. All the cases, the light is moving from water to air or glass to air, means moving from high density to low density. So light strike the surface. Imaginary line which is perpendicular to the surface is called normal. So what will happen moving from water to air? It will bend towards the normal or away from normal? Moving from high density to low density.
Away from normal.
So it will bend away from the normal. So as it bend away from the normal, the angle of refraction will increase. Say this angle was 20 and this angle was 45. Is this a critical angle? The angle
No,
of
it's not.
incidence? Angle of incidence is not a critical angle. If I further increase the angle of incidence, so what happened? The angle of refraction will also increase. So this angle example I changed to 30 and the angle of refraction example it was 75. But again, this is not a critical angle. If I because the angle of refraction is not 90, so it's not a critical. If I further increase the angle of incidence, so if I increase the angle of incidence, the angle of refraction will also increase. And it travel along the surface. So when it travel along the surface, it means the angle of refraction is 90. So if angle of refraction is 90, this angle here, example, this angle was 40. So what is the critical angle in this example?
40.
The critical angle is 40. So critical angle, angle of incidence for which angle of refraction is 90, we call that critical. But if I increase the angle more than the critical angle, so what we will observe, critical angle was 40, I now change to 41. So this was 40, I changed to 41. So if the angle is more than the critical angle, what we observe, is more than critical angle, the light will reflect only and no refraction occur. This
So
is
the
known
light
as,
will come back.
yeah, the light will come back. This is known as total internal reflection. So if I increase the angle more than the critical angle, because at critical angle it was traveling at a 90. But if I increase more than the critical, instead of light will go out, it will return, bounce back in the same medium with the same angle of incidence. And this phenomena is known as total internal reflection. Is it clear? The concept of total internal reflection. This total internal reflection having many applications.
Yes,
So,
sir, clear.
tendency of the light to bend or bounce back in the same medium, but this is different from reflection of the mirror. In mirror, what happened? Because in case of mirror, the light is like mirror is made up of a glass, but light was moving from air. It hits the air to glass boundary and bounce back. So the light was in a rarer medium and hits the denser medium. But in total internal reflection, in short I'm writing TIR, in total internal reflection, what happened? The light is moving in a denser medium, like example glass or water, and it hits the air surface. Like the boundary is denser to rarer. But in normal reflection, it is from rarer to denser. This is normal reflection. But this is having a specific name known as total internal reflection.
So the speed will remain same.
Yes, speed will not change, only the direction changes. In reflection, the speed remains same, only the direction changes. So refractive index is ability of the medium to bend light. We already discussed this. Now about the total internal reflection, the concept of total internal reflection. Example, when a light is traveling from optically dense medium, the term optic is used for mainly for light and eye related. So optically dense medium compared to light, for a light, if a medium is having a high density, it moves to low density medium. So example, light strike the surface. Now the first question is why the light does not change the direction at this point. It continue to move. It does not change direction. This is in air and then it moved to glass. So as it moved from air to glass, the speed will decrease. As the speed will decrease, it should bend towards the normal. But why it continue in a straight line at this point? As we know, light travel from air to glass. So basically why it does not, it changes the speed, but it does not change the direction. Why it does not change the direction? Because when a light strike the surface at the normal or 90-degree, what is the normal to this surface? So this one is this part, this is a part of the surface. This is a surface. And if I draw the normal to surface, so you can see the light is striking along the normal. So when light enters from the direction of the normal, the light will not change its direction. Only thing what happened, the speed will change. So if the question is why there is no change in direction when the light move from air to glass, so what should be your answer? You will mention light is traveling from air to glass and it is passing along the normal. So when it pass along the normal or same as the direction of the normal, it will not change direction. Like if it was in this manner, this is a glass and I draw the normal. This one is a normal and light strike along the direction of the normal. So if the light strike along the direction of the normal, what will happen? It will not change the direction. The only thing which change is the speed. So in air, it will move faster. In a glass, it will move slower. But direction will not change. If it was not along the normal, making certain angle with the normal, in that case, as the speed decreases, it will bend towards the normal. So in this example, why the light does not change the direction when it travels from air to glass? Because it is passing along the normal. Then moving from glass to air, because this one is a glass, moving from glass to air, it bend away from the normal. Is this angle of incidence is a critical? This is not a critical because the angle of refraction is not 90. So this is a normal refraction occur, but not, this angle is not called a critical. And some of the light is reflected. But if we increase this angle, is this a critical angle? Yes or no? Again, it is not a critical angle because the angle of refraction is not 90.
Yes.
If I further increase, now the angle of refraction is 90.
Now
So
it's critical.
this angle of incidence is also known as critical angle.
Critical
Angle of
is shown by I.
what?
Critical is shown by I.
No, angle of incidence is denoted by I, and if you want to say critical angle, you can also say C, small c.
All right.
I is equals to C. Using the critical angle, you can also find a refractive index. Example, if I say this angle was 42 and the angle of refraction is 90. So light is traveling from denser medium or glass to air. Which formula I should use to calculate the refractive index? Which formula I should use to calculate the refractive index? So sine R over sine I. So what I will do, I will use the formula refractive index is equals to sine R over sine I. So refractive index we don't know. Sine R is 90 and sine I is 42. What is sine 42? Sine 90 is 1, that's fixed. What is 1 divided by sine 42? What's the final answer? Sine 90 is 1, that's why I put 1. You can just directly get the value. It is sine R over, it cannot be 0.67. It should be more than 1. Refractive index is because compared to air, other mediums all have a tendency to bend light more than air. So refractive index practically for medium should be more than 1. So 1.49. So 1.49 or 1.5 you can say. Which medium you think will have the highest refractive index? Like as the density increases, the medium will become, refractive index increases. So diamond is having the highest value of refractive index. That's why the diamond, it appeared to be very shiny because the light will bend multiple times when it enters the diamond. So all the parts in the diamond or within the diamond lighted up due to the bending of the light, and it appeared to be shiny. Because diamond is having a high density, then greater the density of a medium, greater the tendency to bend light. Yes, Yusuf, you have a question? Which one? This? Okay. So what happens if we increase the angle more than the critical angle? Then what we observe, all of the light is reflected. We call that as total internal reflection. Then the applications of total internal reflection where we use. You have any concept about optical fiber or fiber optics? This is used for communication, for transferring information or data from one place to another. This optical fiber or fiber optic, how it works, basically, for example, you are using your computer. So this is a computer screen. And this is your CPU, the central processing unit. And the keyboard. For example, the internet service provider or ISP, if you are using any internet service provider, example, ABC. ABC is providing you an internet, which is, you can say ISP, internet service provider. Nowadays, how you link, there are different ways by which you can transfer information from one place to another. Optical fiber or fiber optic is another way. So you're
Again, sir, I
connected.
didn't get it.
What? There are different ways by which you can transfer information or data from one place to another. So fiber optic or optical fiber is also another way, means it's one of the way by which you can transfer data or information. So what it consists of, it is made up of transparent material. So what happened, for example, you type a word, for example, you're searching a word physics. So when you type a word, your computer convert this word into electrical signal, because for a computer don't understand a language, computer language or machine language is a binary language, which is about 1 and 0. So example, you type a word, say example physics. So what computer will do, computer will generate an electrical signal which resemble with or which shows this word physics in an electrical form. And this computer, the CPU, will convert this electrical signal in the form of light. And that light will travel through this optical fiber and received by the internet service provider or ISP. And this ISP,
How does the
just
computer
a minute,
change
let me complete the sentence, then I will answer your question. This ISP or internet service provider will give information back again in the form of light, and then your CPU convert this light into electrical signal and electrical signal into a word output. So you will have a search result on your screen. What is the advantage of using optical fiber or fiber optics? Because the speed of the light is 3 exponent 8 meter per second. So which is too fast. So it's so fast that within an instant you search a word and next moment you will receive the result. And what is the advantage here? Which phenomena occur? Because it is made up of transparent material, this optical fiber or fiber optics. So when the light strike, the light should go out. But because this angle is more than the critical angle, so this angle is more than the critical angle, instead of light will go out, it will bounce back. Same thing, the angle of incidence is more than the critical angle, instead of light will go out, it will bounce back. So it is approximately 99% efficient. Very small amount of light can escape if there is a bend or curve in the passage, but about 99% of the information transfer from one place to another. Yes, what's your question, Hashim?
I was saying that how does the computer, generate light signals?
How a computer generate electrical signal. A computer is having a device which is called a transistor. These transistor acts as a logic gate which produce these electrical signals. Like when you type any letter on your keyboard, actually each letter generate a current. Like example, if I'm pressing a letter A, I press a letter D. So actually each letter is generating a small amount of current. So collectively, when I write a word physics, it will generate a set of a current which can be in the form of electricity. That's why for your working of a computer, you need a power supply. Without a source of energy, your computer does not work because it cannot convert the the letter which you press into electrical signal. But for us right now, our main focus is on this part, that how the energy transfer from one place to another. It's in the form of a light, and light will undergo total internal reflection. So there are no losses. Is it clear? Is it clear the concept of optical fiber or fiber optics?
Yes,
That
clear.
the basic idea is that because it is efficient, it is fast. So that's why most of our communication, which we are doing through the wire, look, there is a sky communication. Sky communication means using like microwaves or radio waves. But there is a communication through wire, which is done through optical fiber. So light in the form, the information which is converted in the form of light will undergo total internal reflection. Is it clear? So it's just a way by which you can communicate from one place to another or transfer information or data from one place to another. The advantage of using optical fiber or fiber optics, it's efficient, number two, and it is a fast process of transferring information. Now we'll do some questions related to topic light. Topic light is not finished. There is a last topic lens, which is also related to this light, that we'll do next class. Now some questions related to the topic which you studied till now. The diagram shows a light travel from air to glass. Four angles are given. Which formula can be used to calculate the refractive index?
It's D, sine W or sine A.
So because it's moving from air to glass, so this is angle of incidence and angle of refraction. So refractive index is equals to sine I, which is W, divided by sine R, which is X. Another question. What's the answer for question 5? So light travel in a vacuum, the speed of and it enters the glass. The speed of a light in a glass block is 2 exponent A. Which statement about the speed of light is correct? The speed in a vacuum is 1.5 times the speed in a glass. So actually the light travels faster in vacuum as compared to that of a glass, and the speed of a light in a glass is 2 exponent 8 and speed of a light in a vacuum is 3 exponent 8. When you divide, what you will get 1.5. So what it shows that the light travel 1.5 times faster in vacuum as compared to that in glass. So that's why A is the right answer. Is it clear? The scout P signals to scout Q on other side of the valley by using a mirror to reflect the sunlight. Which mirror position allow the sunlight to reflect to scout Q? So what could be the answer? Look, A is the right answer because what happened when you check the reflection for B, when it hits, because it is striking along the normal, so it will bounce back in the same direction. So if it hits, it bounces back in the same direction, how it will reach scout Q? That cannot be. For C, it will
Sir,
move in
it's
opposite
D, I
direction.
think.
What?
It's
C, it will be like this. So C cannot be an answer. Same thing, if it was D, then it will go down like this. So D cannot be an answer. So what is the right answer? A is the right
A.
answer. When it hit, it bounced back, angle of incidence equal to angle of reflection. The question is how the mirror should be placed so that the light will reach scout Q. So how it will reach scout Q? You have to make sure reflection, like example, when the light strike, it will bounce back. And how it will bounce back? Because the angle of incidence should be equal to angle of reflection. So when I draw the normal here, so when I draw the normal, you can see angle of incidence and angle of reflection should be same, and the direction in which the light will travel, so it will reach scout Q. But why not B? Why B is not an answer? If he places the mirror in position B, it is strike and it bounce back in the same direction where it strike. So it will not reach scout Q. The prism is made from a transparent plastic. The light travel at 0.8 C. What is the meaning of 0.8 C? C is the speed of the light. The term small c is the speed of a light, which is 3 exponent 8. What is theta? You need this angle. What is the angle of refraction here? Angle of refraction is 90 because when I draw the normal, angle of refraction is 90. So the refractive index is equals to sine r. Why I'm using sine r over sine I? Because it is moving from glass to air, this point. So n is equals to sine 90 divided by sine I. But I don't know the refractive index and I want to find this angle. So there are two unknowns. So first I have to find the refractive index. How I can find the refractive index? The formula for refractive index is, there's another formula, that is speed of a light in air divided by speed of the light in a medium. So speed of a light in air is 3 exponent 8. What is the speed of the light in a medium? They give 0.8 c. 0.8 c means 0.8 multiply 3 exponent 8. Because c, the meaning of a c they mention, that c stands for speed of a light. So 3 exponent 8 will cancel with 3 exponent 8. So what is the refractive index? Refractive index is 1 divided by 0.8. What is 1 divided by 0.8? Or 1 divided by 0.8? So what is 1 divided by 0.8? 1.25. So refractive index is 1.25. Is it clear till now? So what we did, refractive index is 3 exponent 8 divided by speed of a light in air divided by speed of a light in a medium. Speed of a light in air is 3 exponent 8 and speed of a light in a medium is 0.8 times c. They get c is speed of a light in air. So 3 exponent 8 cancel with 3 exponent 8. It's 1 divided by 0.8, which is equals to 1.25. Then you need an angle. So how to find the angle? Refractive index is equals to sine 90 divided by sine I. So, or I can say sine I is equals to sine 90 divided by refractive index, which is 1.25. So sine 90 divided by 1.25. What's the answer? Sine 90 divided by 1.25. It's 0.8. So sine 90 divided by 0.25, 1.25 is 0.8. But we need an angle. Sine 90 divided by 1.25. It will be 0.8. Now we need an angle. In mathematics, maybe you studied this. If we need an angle and we have sine, so a sine will move to other side. So angle I is equals to sine inverse 0.8. So press shift and take sine inverse of 0.8. Shift sine inverse 0.8. What is the answer? So it's 53.1. So that's why D will be the answer. Is it clear? So first we got